Hi guys, David here from Scientific Reactions. So I first found out about this very interesting paper from its summary on Newscientist.com. The article is called "Blasting Plastic with Powerful Lasers Turns It into Tiny Diamonds," and it further observes that a similar process may occur inside giant planets, which could explain some of their mysteries. And the specific mysteries that they're going to try to explain are summarized in this nice article called "Both Uranus and Neptune Have Really Bizarre Magnetic Fields." And specifically, what's weird about it is that if you look at the axes of the planet's rotation and then the axis of the magnetic field of the planet, you can see that in Earth here, they're pretty similar. They're pretty close together. There is some offset, and this is why you've probably heard that the North Pole, magnetically speaking, is not exactly the same place as the North Pole, just geographically speaking. But in Uranus and Neptune, it's really, really different. And this has kind of puzzled scientists for a long time, and there have been a lot of different hypotheses, but I don't think any of them have really been fully satisfying. So in this video, we're going to see if we can understand how this laser shock compression works to make nanodiamonds, and we'll also try to understand and connect the dots between these observations and our understanding of planets like Uranus and Neptune. So the paper starts by talking about the composition of these planets, and this is going to be very important for understanding the paper. It says the interiors of these celestial objects, Neptune and Uranus, are thought to mainly be composed of a dense fluid mixture of water, methane, and ammonia. Because of the high pressures and temperatures deep inside these planets, the material mixture will likely undergo chemical reactions and structural transitions. And one theory for this is that an example of these reactions is the possible dissociation of the hydrocarbons, that is the methane, and subsequent phase separation, allowing the formation of diamonds. In other words, methane, which is CH4, it's a hydrocarbon, they're saying might actually separate, forming metallic hydrogen, and then the carbon part would just turn into diamond. So carbon is purely composed of diamond, except sometimes for small amounts of impurities, which might give it coloration. And then this metallic hydrogen, or perhaps there's other chemical species, they say, like superionic water, may act in certain ways to help change the magnetic fields of the ice giants. So in other words, they think that specifically the formation of certain chemical species in the atmosphere of Uranus and Neptune could be what's throwing off the magnetic fields and sort of basically taking the magnetic field and putting it like almost perpendicular in some cases to the actual geographic pole. And now getting into how they're going to try to prove this, it says that recent laser shock experiments on polystyrene in combination with X-ray techniques for analysis have provided the first evidence for the formation of diamonds in compressed hydrocarbons at planetary relevant states in the laboratory. In this study, instead of blasting polystyrene, they'll be blasting a different plastic called PET, or polyethylene terephthalate. And specifically, what's notable about this particular compound is that unlike polystyrene, which is just a hydrocarbon, it actually contains oxygen as well. So they believe that blasting this material with lasers is going to be more similar to recreating the effects of Uranus and Neptune, where you have a mix of different elements which are undergoing high pressure and temperature. By the way, real quick, I feel like I should just give a little bit more background on the processing approach. As I said before, it's called laser shock compression, and this has been known for a while, basically since the 1950s. The interactions of lasers with materials have been explored, and you have things like laser welding, cutting, surface treatment, etc. But it was also found that you could induce shock waves basically by pulsing a laser into a solid material. And basically these laser shock compressions are considered to be a powerful research tool to investigate the behavior of material under extreme conditions. In other words, if you pulse a laser into a solid state material like a plastic, the type of forces that it will experience are going to be similar to the type of massive forces, massive compressive forces and high temperatures that you might experience in an alien planet's atmosphere. So the laser shock compression, it's not that we think that lasers are being fired around in the atmosphere of Uranus and Neptune, it's that it creates a similar pressure profile as you might experience if you were in the atmosphere of Uranus or Neptune. So in terms of how they're going to actually execute the research, they basically have a dual setup where they have a drive laser that's shown in green here, which is actually the thing that's doing the pulsing, and they're pulsing into a small space on a piece of polyethylene terephthalate plastic, And then they have X-rays, which are being which are useful for trying to figure out information about the material. It's kind of like probing the material with X-rays while you're blasting it with a laser so that you can see what's going on. And they have two different techniques. They basically have what's called X-ray diffraction, or XRD, and they also have SAXS, or SAX, which is small angle X-ray scattering. And the XRD is going to give them information about the crystal structure of the materials, which can help them identify what is being made. And then the small angle X-ray scattering is going to give them information about the size of the things being made. So you can think XRD is going to identify what they're making, and the small angle X-ray scattering is going to tell them how big the things are that are being made. And so basically what they're going to be doing is they're going to be pulsing the plastic with lasers, and they're going to be observing changes in the material. So we're going to be seeing these transformations take place, and also find out about maybe like the particle size of the things being made. And in figure 2, they start to analyze it, and basically there's a lot of science going on here. But what they're finding out is, thanks to the X-ray diffraction, they are observing that there's actually diamond being formed as they pulse the plastic with a laser. And meanwhile, the small angle X-ray scattering is giving them a sense of the particle size of the diamonds. And the diamonds are very, very small. They're about 3 nanometers or so, 2 or 3 nanometers. And what they're finding is as they pulse the plastic with a laser, it is forming nanodiamonds in real time. That's the main result of the experiment. But of course, that's all very well and good, and it's pretty exciting, but what does this have to do with Uranus and Neptune? Well, this figure is really interesting because what it's doing is it's showing a phase diagram of mixtures of carbon, hydrogen, and oxygen. In other words, it's showing us sort of the pressure and temperatures that you would expect different materials to form if, from a mixture of carbon, oxygen, and hydrogen. And you can see here that there's a region, if you're sort of in the 100 to 150 gigapascals in terms of pressure, and maybe between 3,000 and 6,000 degrees, you would expect to see diamond formation within this specific region. And then we have overlaid on the same figure, we have lines that represent kind of the pressure, temperature regimes of different planets. And so you actually see the blue line here, according to some sources, is actually the pressure and temperature region for Uranus and Neptune. And overlaid with that is these green triangles, green and yellow triangles and whatnot, show the actual conditions of the experiment. So the fact that these two lines, the dotted green line and the blue line, intersect in the diamond formation region shows that they're similar enough that you're actually getting similar conditions during your laser shock experiment that actually emulates the conditions of Uranus and Neptune. That the fact that you're seeing diamond formation in this region, from our experiments, confirms that there's a very good chance that the same type of stuff is happening in Uranus and Neptune. Again, not using lasers, but just the fact that we're reaching the same pressures and temperatures. So how does this tie into the magnetic properties of Uranus and Neptune? Well, the idea that's very interesting to me is that, like the atmosphere of Uranus and Neptune, which has a mixture of different things, what we're showing is that by blasting this particular mixture that has carbon, oxygen, and hydrogen, you're able to actually form the nanodiamonds. And the nanodiamonds are composed of 100% carbon. And so what that means is the carbon is separating away from the hydrogen and the oxygen, and you're getting the chance to form water or potentially metallic hydrogen or oxygen. In turn, these phase-separated materials, this metallic hydrogen or the superionic water, these are highly magnetic materials. And so if you have eddies and swirls of these materials kind of moving about in your planet, maybe they're moving with like thermal conduction, because of just like storm systems and things like that, you've got like huge amounts of magnetic material circulating throughout your atmosphere. This is something that actually is plausible that it could be throwing off the magnetic field altogether. So in other words, the atmospheres of planets like Uranus and Neptune could be absolutely chock full of, maybe nanodiamonds and microdiamonds, and this is kind of interesting, maybe not just nanodiamonds and microdiamonds, but maybe like large diamonds, but that's creating this imbalance where you're creating these other materials which are highly magnetic. And so the diamond itself is actually inert, magnetically speaking. It does not really have a magnetic field to speak of, but these other materials would be highly magnetic. So going back to the paper that talks about how both Uranus and Neptune have really bizarre magnetic fields, it does confirm this idea. They say that both planets are thought to host large convective layers, somewhere between the core and atmosphere, where superpressurized water and methane exist in a superionic state with properties of both liquids and solids, and it's circulating in up and down patterns, and since they're charged, the planets might generate their magnetic fields there rather than the cores. And what this paper that we read today is doing is it's kind of saying, well, actually with this diamond formation, not only would you have the superpressurized water and methane, but you could have metallic hydrogen in there as well, which could be a potent contributor to this overall magnetic effect. Anyway, if you enjoyed this video, please go ahead and hit like, and I hope you'll join me again in the future soon.